Well, thanks for letting me talk to you today. It's actually been a while since I've done an SBE meeting, but we've done an AFCCE and a couple others, but a lot of interesting things going on these days with the company that I'm consulting with, GEO Broadcast, in the area of boosters, FM boosters. So put this here. So I'm going to give you a little bit of background on boosters and some of the theory and stuff that we've had to work out to get these things to work in the way that we have them working now. In 1986, the FCC allowed us to do high power boosters. Before that, you actually literally had to pick up the main transmitter, run a wire over the hill, and then run a directional antenna with 1 watt to cover your area. Didn't work very well. So they opened it up in '86. Restrictions are that obviously it has to be the same frequency as the main. The primary contour must be inside the primary protected contour of the main. Secondary status obviously can't cause interference to other stations, but it can cause interference to the primary station, except in the community of license. It can operate at any height, but not at over 20% of the maximum class power. For instance, 10 kilowatts for a class B. And you can feed it in any manner that you'd like, but obviously you must have positive control. So the things that we've learned over the years through a lot of testing and some spectacular failures that I've had over my career, the carrier and pilot have to be locked together, as do the phase. We do that with SynchroCast and 10 megahertz reference, and I'll get into phase in a little bit. Modulation has to match within 1/4 of a dB, which is pretty tight tolerance. Currently, we're using digital composite, AES-192, which works out quite well. That way you can lock in everything, phase and stereo pilot and modulation and all from transmitter to transmitter. We use the Gatesair IP link with SynchroCast for real-time synchronization. The stability node to node must be within 3 microseconds. Beyond that, you start to lose your synchronous. So the antenna has to be chosen in a way that you reduce the delay spreads so that you can maintain that 3 microseconds between nodes. And we found that there are some pretty unique issues implementing HD with boosters. We've worked them all out, and I'll get into that a little bit shortly. So one of the things we found initially was that people said, well, there's interference with boosters. And so we said, well, how much will listeners put up with before they'll tune it out? And so GEO did some subjective testing using the same people that the HD radio folks used to determine what the quality of transmission needs to be for HD radio. And they enlisted NPR Labs and Towson University to do subjective testing. And we came up with this keep-on score. The idea is that interference needs to be kept to an area where 90% of the people, that's this purple area up here, will stay tuned on their radio in the presence of interference, co-channel interference. So let's talk about what interference is. This is showing you what happens in Chicago. This happens to be just, on paper, WLEY, but on paper, we put a non-directional co-channel booster on the map here. And so I showed you in the previous one where we have the 90% keep on. The magenta color here is areas where it falls below the 90% keep on. So as you can see to the right of the booster, it's not so bad. But obviously you're destroying probably half of your coverage area because there's no way to keep it synchronized. So this is how we would put one node in. We call each booster a node. This is synchronized with a log periodic antenna at 105 degrees, which is 180 pointed away from the main. This one's 99 watts, and in order to synchronize the propagation, it's set for a 90 microsecond delay. So what happens if we screw things up a little bit? Well, if we boost it 15 dB in power and keep everything else the same, you can see that we're getting some interference along the outside edges here. And obviously we need to keep away from that. So you can't overpower these boosters. If you don't have the antenna orientation proper, then you get interference. In this case, if you're tilting it north, you lose to the north. If you tilt it too far south, you lose it to the south. If your timing is off, this is a, what is it, 12, I think 12 microseconds. Anyway, it's more than 3 microseconds off. You can see that you create interference in that case. And if you go up by 10 microseconds, then you create interference in this way. So rather than overpower the boosters and create interference, we actually do multiple boosters. And that's how we can cover a large area without violating any of the technical parameters to keep the interference down. So not only do you have to then synchronize with the main, but you have to synchronize between each booster. So it gets a little hairy getting this to work properly. So GBS specializes in the planning and deployment of these boosters. We use modern cellular technology and cellular software tools to determine what the coverage is and how to calculate coverage and interference. We found that about 80% of the stations have some impaired coverage. You may not care about the area where you have impaired coverage, but the rim shot stations and stations that are outside of the target market tend to have some issues that we can help with. MaxxCasting is a proven system now. We have, I believe, 50 nodes on the air, somewhere around that total, to get these results. So we've really been able to roll these things out. In order to measure the coverage so that we know exactly what the signal levels are, because if you don't have an idea of exactly what the levels are, you can't design the system. So we use the MC5 with Golden Ear, and we use a propagation tool that's used by the cellular folks. It's a very extremely expensive software tool, ATDI ICS Telecom. We also have just started doing testing and measurements using the Nomad measurement system. That also gives us the ability to do measurements for HD. So this is what it looks like when we get our signal levels back from the field. In this case, you'll see on this chart to the right, the yellow and the green. The measured numbers are yellow and the predicted is green. And ATDI will adjust the model to the point where we have better than 95% correlation between the measured and the predicted. We obviously don't use Longley Rice because it's just flat out not very accurate. We use a model called ITU 525-526 with Daegu diffraction and subpath and ground reflections. One of the things that we found, which you may have learned yourself, is that where signal isn't great, you don't get your watermarks for your ratings, for your Nielsen's. And these are measurements that we've done, in this case for Boston, where you can see the blue dots are places where the PPM code is not being reliably decoded. And then after we did the boosters, the red is virtually 100% coverage. So that made a big difference in their ratings because the people could actually hear it and they'd get credit for it. Two very good outcomes. But to give you an idea of what the Boston situation was, on the left, you can see that the blue, we say blue is bad, but blue and the white area means very poor coverage. And then we've added the nodes in the right. This is for 3 nodes. And you can see that the coverage has gone from blue and white to pretty much all yellow and green, which is good coverage. Now, when you get up into the yellows, then you've got good in-building coverage. To show you the kind of detail that our terrain database uses, this is what the before measurements looked like for WXLO in Boston before we did the work. You can see that the detail is that we actually have all of the streets, all of the buildings, at least all the bigger buildings, and that's all in the database, and that all calculates out to come up with your model. And it's amazing how much a building attenuates the signal. We found that in New York, shooting from one side of Manhattan to the other is about a 20 dB attenuation that Longley Rice doesn't even pick up because they don't have that in the database. But after we did the work, this is what it turned into. So you can see it goes from this blue to yellow and green and even a little bit of orange there. So a significant improvement. We also, in the case of Boston, did some drive testing, and we used a special system for this. We don't use this often, but you can see that the recovery, the sound quality in the field in the Boston area, which is right in the center there, center right, goes from virtually nothing to full coverage. And by the way, in that situation, they went from not being carried in the tunnels by the city to being carried in the tunnels. So they really went from a unlistenable rimshot station to a full market Boston urbanized station. Recently, we've done a KWFN in San Diego. This is what KWFN looked like. This is the first implementation of FM plus HD. You can see up on the upper part of the screen, there's a lot of white where those mountains pretty much block all the signal. After we add the nodes, this is what we come up with. The white spot that's still there, nobody lives there, so we didn't worry about that. But you can see that there's a significant improvement. This is the HD measurements that we did. On the left, you can see that the HD was not recoverable prior to the boosters being put on the air. This is using that Nomad test equipment. All the red on the left, and then you can see on the right, the red areas have pretty much turned all to green. There's a couple of transition areas where you drop out of the HD, but it's a huge improvement, and they seem very pleased with that. closest to you, we have KDDS in Seattle. This is a rim shot from pretty far away to the left. You can see on the bottom left corner the main transmitter. And you can see that over Seattle, there's blue. And if you've ever been up in that area, listen to those stations, you know that they just don't come in very well. So we added some boosters. At the top there, you'll see FM1. That was before we did composite contours. We were doing this, but we can actually do boosters within boosters, but that's actually a composite pattern. But you can see that we're lighting up downtown Seattle and pretty much all of the downtown, all of the I-5 corridor, going pretty far down into Kent. So before and after. So we're working on right now a big project with Bonneville. We're putting 3 stations on, and each station will have 5 booster nodes. So that's 15 booster transmitters. It's a pretty big project, but we've been working on this one for a while, and we suspect that after Bonneville gets on the air, we'll probably have a number of stations. But in San Francisco, I don't know if you're familiar with the San Francisco East Bay Hills, but they do a really good job of blocking the signal. You can see in Concord, Walnut Creek, San Ramon, Livermore, and Pleasanton there, it's pretty much non-existent. So some stations have put a booster on the air from Diablo, and this is what they've wound up with using that booster. They get a little bit of coverage in some areas like central Concord, but they also create a huge amount of interference for themselves because the booster is pointing back toward the main, so they can't synchronize the propagation. This is the 5-node MaxxCasting system that we'll be putting on the air. For the first time, the area up on the north end there, Antioch, which is the highest growth area in the Bay Area right now, will be getting signal, and we'll have office listening in Walnut Creek and listening all the way down 680 into Pleasanton and coverage into Livermore. All of this is fully synchronized, and as you can see, while there is some interference that's relegated to the tops of the hills there, it's a significantly less interference than what most of them have going on now. This is something else that happens in San Francisco because of the Diablo Booster. You'll see on the bottom of the screen there, the Diablo Booster is so high that it shoots over the East Bay Hills and causes interference at the edge of coverage for a lot of the stations in San Francisco. A lot of stations in San Francisco didn't care about this when they put this on the air in the late 80s, early 90s, because who cared about Silicon Valley? Well, obviously that's changed. So now everybody's complaining about this interference that they have down there, and the MaxxCasting system will overcome that. We've calculated that the interference from Diablo interferes with almost 500,000 people, and it's a huge improvement when they. It's not so much a matter of coverage in the East Bay, but loss of interference in the South Bay. These are the partners that we typically use. Gatesair, SCMS. Doug is represented here. They help us out a lot. They know what what we use in all the systems, and it gets pretty hairy when you actually got 15 boosters going on the air. It's a lot of small parts and a lot of big parts too. And we're just getting ready to put all that stuff on the air now here in San Francisco. We use dual log periodic antennas. We have to use 2 of them so that we can keep the side lobes down. High capacity microwave or data circuit need about 3 to 5 megabits per node. So if you've got 5 nodes, then you want to have about 25 megabits at the origination point, which is your main transmitter usually, and then 5 megabits up and down at each of the node locations. Has to be low latency, and then you need even more if you're adding E2X for HD. We use the Gatesair IP link systems with Synchrocast. We standardized on the MPXP digital composite. And if you're using HD, we found that you have to use stream splicing and preferably 2 different data circuits for reliability. The exciters and the software versions must match exactly so that the throughput timing and the modulation is all matched perfectly. We've got it working currently on Gatesair and Nautel exciters, and it has to be one of the newer importer exporters. As I mentioned, we now have HD operating with HD main with analog, or HD main with analog boosters, or HD main and HD boosters. Obviously, we also do analog with analog, but we've got the HD on the boosters at KWFN, WKVB in Boston, and KSBJ in Houston. So after we get MaxxCasting, we were wondering what else we could do that could help the industry. So we've looked at something called ZoneCasting. And this is everything that MaxxCasting is, except that for 5% of the day's programming, the boosters would actually split off from the main and have separate programming. Obviously, you can't keep it fully synchronized if you have separate programming. So we've come up with some ways to do quick transitions between the main and the booster or the zoned areas to make that happen. We're currently doing tests in KSJO in San Jose, and also we're starting tests at WRBJ in Jackson, Mississippi. So this is KSJO in San Jose. The main, as you can see, doesn't cover that area. 400,000 listeners live there. So in 2019, we put a regular booster on the air there, and it, as you can see, does a pretty good job of filling that area in. And if you look down there where it says transition area, that's basically the only way to get from the South Bay into the East Bay by roads. It's very well protected. That whole area is kind of in a valley, and there's very limited ways to get in and out. So what we did was we took 2 boosters, one pointing up to the northeast, as you can see up the 680 road, and one to the southwest. The one to the southwest duplicates the main, and the one to the northeast is the zone area. So the one to the northeast down here, where it says KSJO FM2, is synchronized with FM1, and the one on the lower left is synchronized with the main during ZoneCasting. And this is what you wind up with. This is on the left, what the valley looks like, and you see on the right here how the zone breaks out between the main and the zoned area. 680 in that transition area that I showed you. When you're driving on the road, we have to make that transition very quick, or else, you'd have a long period of time where you're getting both the main and the zoned area. And as you can see here, we actually keep, by doing the back-to-back antennas, the transition area is kept to maybe about 200 feet. And I've got some audio I can play here in a little bit if we have the time. You can see what it actually sounds like going through that transition. So that's what I've got so far, and I've got some audio if you want to hear it, if we have time.
Yes.
What do you say, Kent?
We have time.
Okay. Can you hear that? Were you able to hear the audio?
Yes.
Yeah.
Okay, so keep an eye. This is in MaxxCasting mode, and this is testing the HD transition. Xperi has been very interested in this, and they actually had a crew come down and listen to it. Keep your eye on the HD indicator, and you can see where you're transitioning from one node to the other. Oops, I'm sorry. You can see that transition is pretty darn clean. I would, if you weren't watching the screen, you wouldn't know. And that's actually going from one synchronized transmitter to the other. Obviously, because they're different HD generators, you lose the HD for it to recapture. We're working with Gatesair and with Xperi to synchronize the exporters so that it can go from one to the other without dropping it for more than about a second. Okay. The video in this isn't very good, but at about 28 seconds, it goes from a traffic report from the Bay Area to a traffic report for the East Bay. And I don't, if you can look carefully, you can see the timing on the bottom about where it is, but it's a little more than halfway through is where the transition is. And this one you could hear because it's two different voices, or it's the same voice but saying two different things.
Or call 510-579-5211.
Northbound 101 in San Francisco, just after Cesar Chavez, an accident there on the right shoulder. That's pretty much the slowest traffic in the Bay Area right now from Cesar Chavez trying to get to the lower deck of the Bay Bridge. Northbound 880, slow and go, starts in Fremont, Dakota Road, continues up towards A Street and Hayward. Looking at San Jose, southbound 101, open stretches from Lawrence Expressway to Oakland Road. Also some minor slowing southbound change to about Hacienda. From there, looks good in the Livermore, slows again, Greenville up the Altamont Pass. That's traffic. I'm David Bruce.
You are listening to the only station to sound.
So I'm not sure if you were able to notice where I made that transition. It was back here at about 28 seconds. I'll come back here and let you listen to it. It's about 5 seconds after I started here.
Oakland Road, also some minor slowing southbound change to about Hacienda. From there, looks good in the Livermore, slows again, Greenville up the Altamont Pass. That's traffic. I'm David Bruce.
So it's a pretty clean transition. We were very pleased with how that works. And we have a petition for rulemaking pending at the FCC to allow separate programming for a limited period of time each hour so that we can bring this technology to the listeners and the stations. we did a commercial test with Jack in the Box where they had separate commercials promoting their East Bay stores as opposed to the San Francisco area stores, and they were extremely happy with the ability to do the zone casting and have different spots. So that's what I have. Any questions? Everybody's still asleep? Did I put everyone to sleep?
No, Eugene here.
Presentation.
We stayed awake.
Oh, good.
Hey, Bert, it's Nick over at Gatesair.
Hi there.
I was just really impressed with the coverage improvements. That's you don't see that every day. That was nice to see.
Yeah, we are very pleased with how the coverage improves, and even when we're doing the zone casting, it operates in MaxxCasting when it's not doing zone casting. So, but yeah, every place that we've implemented these has improved their ratings. I hate to say that because it's always such a fickle thing that we have, but so far it's 100%. Some of them less, some of them not as much as others. WXLO in Boston doubled their rate, more than doubled their ratings and their revenue, by the way, with the improvement in coverage. So it depends on the situation, but everyone that's put these in have been able to translate that into additional revenue. In the case of San Francisco, we believe that about 1 million people who are currently either through interference or a lack of signal unable to hear the Bonneville stations will be able to hear them after we add this. So 1 million people has to be worth something.
I know on the stuff that we did for KDDS, Bustos, and I remember when we were working on that, I think they even the tower sites for like Crown Castle, it didn't take a lot. It was like really.
Yeah, they're American Tower.
American Tower.
Yeah.
Yeah, but I thought they were almost like cell phone towers or something. I remember they didn't need much, to build out each site with the nodes. That's right. Another nice feature.
Yeah, they don't need to be up real high.
Right.
So cell towers typically work pretty well, especially if they're on a hill, which most of them are. And in fact, in order to control the propagation, you don't want them really high, because if it gets too high, then the delay spread gets to be too much, like I showed you earlier in this thing, and you generate self-interference. So it's definitely a cellular approach to doing FM boosters. So there you go.
Well, from Eugene, thank you, Bert, for the presentation.
My pleasure.
And, it looked good, very informative.
Thank you. And by the way, if anybody is interested in learning more about this, if you'd like to see a copy of any of these slides, or want to learn more about how the MaxxCasting might help your station, contact either Doug or me, and we'll get you taken care of.
Yes, sir.
I think Doug's still there.
I'm still here. I'm still here. Was there any other business that you wanted to handle?
Oh, sorry?
Is Kent still on us? Still with us?
I think he is.
All right.
Yeah, there he is.
Kent, did you have any further business?
Kent is out of the room for a moment.
Oh, gotcha. There he is.
There, Kent, you're getting called.
I left the sign up clipboard out in the car.
Yeah, if you'll send me those email addresses, Kent, we'll send a Grubhub certificate to the people that attended the presentation.
Oh, cool. Thanks, Doug.
Thank you.
Have to get creative in the time of COVID, take people out to lunch.
So how many people do we have from Medford? Bryce, I think, was in the chat to say that he was in Medford. Anybody else? I don't recognize any other names here. So we might be done.
I think so.
I guess so.
From Eugene, thanks, everybody.
Thank you, fellas. Appreciate your time.
Yeah, thank you, folks.
Good seeing you guys.
All right, take
Good to
care.
see you.
Take
Take care.
Later, fellas. Bye now.
Bye.
Bye-bye.